Guys and girls, it's Noah time! Hey, let's get crack-lacking! It's Noah time! Noah time!
Wait, not yet. I'll do it in a second. Whoa, I'll do it in a second. Here we go. I want to do a quick review first. Review. My brother actually chose 1, 2, 3, 4, 5, 6, 7 once, and he didn't win anything. But now my question to you is, if I chose 1, 2, 3, 4, 5, 6, 7, would I have the same odds as winning as anyone else? Yeah. Exactly the same thing. Because my number is the exact same odd as your number. Even though your number is so ridiculous you would never win, I can say the exact same thing about your number. Okay? The odds of winning we calculated is about 1 in 85 million. Now, is it my time to go? Who knows? It may be my time. Review. I started yesterday teaching you exponents. Y equals to, I give you two numbers, 2, 3, x. But instead of writing like this, I'm going to rechange it this time. Because a lot of you can work with numbers, but not everyone can work with variables. Y equals to a, b, x. This is where it gets a bit more interesting. Okay. B really determines if it's increasing or decreasing / decrease. Okay. If b is greater than a magic number, we say it increases. I've taught you this yesterday. If b is greater than 1, it's an increase. That's how we work it. Okay. We know it's an increase. And you can draw a quick sketch of it. Very nice. Very simple. Okay. So guys, girls, I want to draw an increasing graph. Tajbir, what's the end behavior from where to where? 2 to 1. Manraj, what's your x-intercept? None. See, x-intercept, a lot of you ask me to know, do I have to know the x-intercept? Yes, you do. In this case, x-intercept is none. Okay? Well, you can't solve it yet because it doesn't exist. If it exists, I will tell you how to solve it. But since it doesn't exist, you can't solve it. So this is called an increasing function. And really, this, for now, represents your y-intercept. That's what it represents. That's your y-intercept. Okay? Because, for example, if it's 2, 3 to the power of x, my y-intercept is 2. That is what we did yesterday. Today, I want to give you actually one more question, and then we'll start with today's stuff. Try this one. Y equals to 3, open bracket, 1/2 x. I'm going to ask you for a few key things. 1, my x-intercept. Y-intercept. Okay. I'm going to ask you for domain and range. I'm going to ask you for, is it an increasing or decreasing function? I'm going to ask you for, what is the base going to be? What is the base of the function? Okay. So guys, I'm going to pause it, let you just have a few minutes to work on your own, and just try this out. Yep. Harjaz, what's your x-intercept? None. Okay. Taryn, what's your y-intercept? 3 is correct. Ender, domain. All reals is correct. Range, Mario, range. This is a bit tricky one. Good. Yes. Now notice Mario says greater than 0. There's no equal sign because it will never touch 0. Navdeep, increasing or decreasing? Decreasing is correct. Hema, what's the base going to be? 1/2. It's correct. So guys, gals, what base really refers to is, what is the base? The base is really 1/2. X is called the exponent. Okay? I could put this in brackets also, but 3 is not the base. Okay? So again, the base, this is your exponent, agree? This is called the base. But today, that was easy. Today, I want to show you more functions on your calculator. Today, your lesson is on exponential regression. So this is where you got to be really good with your calculator. I've taught you line regression, cubic regression, quartic regression. Now we're going to do exponential regression. To start off with exponential regression, I have a data table for you. You're going to plot this data table, and I want to see who can come up with exponential regression. You can do whatever you like. Without my help, let's see if you can figure out where the key is, where the button is. Whoa, whoa, whoa. I will do it later, not yet. I just got to dig up an exponential graph chart for you. Yep. Sorry? Real numbers means you can have anything from negative infinity to positive infinity. It counts everything. Yep. Domain, because the graph keeps going. Because when I graph out my exponential graph, here's the reason why. Notice it keeps going all the way to the left and all the way to the right. So it never ends. You can go as far left as you want, as far right as you want. That's why. So guys, gals, try this year. Population of Canada. 18, way too noisy. 71. 1881. 1891. 1901. 1911. 19. I'm going up by 10. 21. 1931. 41. 1951, 1961, 1971. So, population of Canada, I'm going to make it easier for you, and let's call this in terms of millions. This is 2.44 million. So, if you had gone back in time to 1871, Canada's population was basically the whole size of Vancouver right now, or BC right now. For $500, you can buy yourself a piece of land and house. Yep. Sorry, this is 3.23. 3.74. 5.42. 7.22. 8.80. 10.38. 11.51. 14.01, 18.24, 21.57. Our population right now, I believe it's around 30 million. Okay? 33? Oh, okay. I'm off by a few million. So guys, gals, I want you to plot this on a scatter plot, and then let's see who can figure out where the exponent regression function is. I'm going to pause it. Let you have some fun. Go. If you're lost, let's work on this together. Grab your TI-83. What we're going to do now is I'm going to clear all this up. I go y equals, I'll make sure your y is all clear. There should be nothing in your y stuff. Go stat, edit. Now we'll bring you to the screen. So again, we just go delete all this stuff right now. Or I just go 1871, 1881, just punch it in. 1891, 1901, 1911. I'm gonna pause it and just fill this in. So guys, gals, the table is entered now. Make sure you enter your plot 1. Enter. Make sure it says on. Go to scatter plots. And everything should be highlighted the way it is. Make sure your Windows mode. Here comes the key part. I'm going to make my Windows mode maybe 1870. as x min. X max, I'm going to make it maybe 1975. Now for the x scale, I'm going to make it maybe equal to 10. Okay, which means 10 units worth. Yeah, I could too. 1980 makes it easier. Y min, I'm going to make it maybe 2. Y max, maybe I'll make it 22. And for the scale, I'm just going to go up by 1. Nope. I look at here as to determine what the min is I should use for my Y min. And look at here to see what the Y max I should use. Okay? So I use 2.44, but I want it just a tad bit lower. So I want to see the whole thing. And I want you guys to hit graph. If I hit graph, say, oh my gosh, look. It looks like a nice exponential graph. So what you're going to do now is you come up with an equation for the grid. So what I have is, let me just insert. There's my grid. If I were to draw a line that best fits, it looks like an exponential graph right there. Okay. A nice curve like that. So here is how we find your exponential curve thing. You go second. What is it? Nope. You go stat. Calculate. All the way down. 0. Look, there's the exponential graph hidden right there. Hit enter. We'll hit enter one more time. So look, there's that A, B, X I was talking to you about. A is 9.25 to the power of negative 18. Oh, it's 9.00? It's fine. So we're going to rewrite this down as y equals to, question. For which one? For A, 2.67? Your graph should show up like that. Okay, so you got 9 point what? 23, right? Calculate, you go, it won't, everyone should be in the same and then, I don't know why. Exponential regression. Huh, I still have 9.1 points. You should have a value of around roughly 9 point something. Now this value will differ according to how you input in your calculator. Some of you use 0 as x and, what was that, Nesh? So 0, 10, 20, okay, that works. Yep, but then that will give you a different thing. Okay? It's the same concept, so I'm going to rewrite down what this is. So this is 9.25 or 26 times 10 to the power of negative 18 times 1.0217 x. This is your regression. Yep. Yep, it's fine. You have to keep it the same format, exactly what you do. Yep. Yep. You would have to input the years from there. Okay? So I'm going to show you an example. My part B is this. It won't matter. B. What is a population? Let's see if it matches our population of your model. What is a population in 2012? Harjaz says our population is around 33 million. So guys, gals, I want to see if this model holds true. You predicted a model. Let's see if it holds true or not. So this is where everyone's work will be different depending on how you put it in your data table. For me, you could. For me, I'm going to just sub in 2012x. So take a minute, punch in your calculator right now. 9.26 times 10 power negative 18 times 1.0217 to the power of 22. 12 because I let x be the years. Okay. Punch it in your calculator. I'm going to pause it and let you guys. So if you use your calculator and plug it in, you should have 53 million. Did you? Well, what did you get? Okay, something's wrong with your work. I'll go check in 1 second. So guys, if we use this model, we should get 53 million, but apparently our population is not at 53 million. So this is called exponential regression. Now, part C, I'm going to show you a new function. When will the population Nope. Yep, you're going to work backwards. I'm going to show you how to work backwards now. Reach. So let's say we want our population to reach 75. Actually, no, we'll do it smaller. 30 million. When will the population reach 30 million according to this model? I'm going to show you how to do this right now, because let's write down what you have. You have y equals to 9.26 times 10 to the power of negative 18 times 1.0217x. See, we're not subbing in 30 for x anymore, but this is your y value now. So I'm going to show you how to solve this now. Before I said you're not ready for it, now you are. So this becomes 9.26 times 10 to the power of negative 18. 1.0217x. Here is how you're going to use your calculator to figure out x. In order to do this, go grab your calculator. Hang on, what you're going to do is you're going to graph this into your y1 and y2 equation right now. So under y1, you're going to punch in exactly this formula right here. 9.26 times 10 to the power of negative 18. You're going to graph it, yep. 9.26. I will. 9.26 times 10 to the power of negative 18 times 1.0217 x. Okay. Your Windows mode will be kept the same. Only difference is I want you to change the Y max so that includes that number 30. So I will change it to maybe 35. Okay. Hit graph. Oh. Sorry? Windows mode, yep. There's my Windows mode. Okay. For which way? You just keep it exactly what you did before. But now I'm going to show you how to graph. Once you get your curve, what you're going to do is plot in y1. But now the question says, when is it equal to 30 million? So here's the last part you're going to do. Hit y equals 2. This is your original curve. Under y2, you're going to hit and punch in 30. Because they want to know when it hits 30 million. So punch in 30 right now. Then hit graph. Then it's going to create two lines. Oop. It's not going to show because it's a bit. I'm going to need to change the Windows mode again, guys, because it doesn't show when it hits the two lines. Change your Windows X max to maybe 2020. 2020. Because I want to see when it intersects. So here's my curve. Right there. The point of intersection is when it occurs. So I want you to change your Windows mode to 2020. Oh, under Y2, I hit 30. Because I want to know when it hits 30 million. So hit graph. The point of intersection is when is the number it occurs at. So I can play the guessing game, take your little cursor key, and find the X value when it reaches 30 million. Okay, we can play the guessing game. And it tells you the date right there. 1984, I can play 1986. But the problem is this, we're guessing. So there has to be a more precise way of figuring this out. And this is your last function you need to know how to do 80. This is called the intersection one. Go second. Calculate. And there's something called, go to number 5, says intersect. Intersect means it will find exact coordinates. When? Oh, sorry, I'm going to do it again. Ready? Second, trace right now. And there's that intersect key right there. Intersect means where is the coordinate it's going to find for you. Hit enter. It's going to say first curve, which means on any line you like. So it's on the curve right, which means this is my first curve right here. Hit enter. Now it's going to set second curve, and it'll say, is this the line that it wants you to intersect? Hit enter. Okay. And I hit guess again, and it's going to give you exactly 1985. That is now how you work backwards to find everything. So what you got to do is plot out under y1 and y2. So my answer, when is it going to hit? The answer is 1985. Voila. I'm going to give you a question for you to try on your own, and then I'm going to work on it, and that's it for today. I want you to graph this and answer a few questions. Time. Hi. Sorry, say again. Why did I multiply 9.26 by 10? Oh, because when I do the exponent regression, watch what happens. I go stat, calculate, go to exponential regression. I hit enter. Notice it says 9.26 e to the power negative 10. E means times 10 to the power negative 10. Okay. Time. Temperature. 0, 5, 10, 20, 30, 40, 80, 69, 61, 45, 34, 26. Rough sketch, rough work. My question to you is this. I want you to A, do an exponential regression. B, I want you to find temperature at 12 minutes. C, I'm going to ask you at what time will the temperature be 40 degrees Celsius. Guys, have fun. So again, I'm going to work on it with you. Clear my calculator. Make sure everything is clear. Go to the y equals to. Clear all this out right away. You have to clear your y1 and y2 out. Stat. Edit. You have to clear everything, or else it's not going to work. Okay? I'm going to delete all this stuff right now. Just go there and go hit delete. There's the delete button. Yeah, or you reset your memory. So I'm going to make sure everything is clear because you don't want any data to destroy your results. Okay? Y scale? You can go whatever you like. So again, I go 0, 5, 10, 20, 30, 40. Okay. These are just rough points. 80, 69, 61, 45, 34, 26. Make sure your Windows mode is set properly. So again, I want to set X min to 0 maybe. X max I'm going to set to 45. Scale, maybe I'll choose 5. Again, this is where everyone's different. My grid, my equation may differ from yours. Y min, I'm going to set it to maybe around 20. Y max, maybe 80. My scale. Oh yeah, good point. 100. My scale, I may want to set to 10. Everyone's equation will be different, but in the end, our results will be the exact same thing. So what I'm going to do, I'm going to hit graph just to see what it looks like. It sort of looks like it's going exponential decay. So now we're going to do regression on this. Stat, calculate, exponential regression, hit enter. You got to hit enter one more time. This is a mistake students make. They got up to the screen and they just leave it alone. Hit enter one more time. There is my value. There's that A value, there's the B value. So I'm going to rewrite this as y equals to, again, probably best around to 2 decimal places. Y equals to 79.89, open bracket, 0.97 to the power of x. This is your A value. This is your B value. And this is the answer for A, yes. Now, it says find the temperature at 12 minutes. See, x is my time. I just plug in my calculator right now. I go, so we can just plug this in. I go second quit. Second quit. Clear all this stuff out. 0.97. Make sure you hit exponent first. To the power of 12. Times 79.89. So the temperature will be 55.43. So this is going to be y equals to 55.43 degrees Celsius. Guys, I'm going to pause it. Now C is a bit more interesting because you're working backwards. To work with C, hit y equals to right now. And what you're going to do is put this equation into your graph right now for y1. So I go 79.89. Something's wrong. 0.89. Open bracket. 0.97. To the power of x. Right there. Now for y2, Kyla, what are we going to put for y2? 40. Because I want to see where it intersects. So look at my graph. If you did this right, your line created will try to match all the points as much as possible. Okay? There's that intersection point right there. What I'm really looking for is, what is the x value when it hits? Now I can use the guessing game, or I can find the exact value. Guys, gals, find the exact value for me. I have a question. Are you talking about y2? Are you talking about y2? I chose 40 because I asked you when it's going to hit 40 degrees Celsius. So I want to know where a horizontal line, so exactly that intersection point. Okay? Good question. So now, 22.71, we'll find out. I don't know yet. Second, intersect. My first curve, enter. Second curve, correct, hit enter, enter. Cross your fingers, 22.7 minutes. Question?
How do you know where do you put the cursor in second curve?
Your cursor one of your cursor should, it doesn't matter. The cursor should be either on the straight line first or the curved line first. Sorry? It should be default, yeah. Harjaz, question. How to get B for which one? Find the temperature at which one? Oh, for B? So what I did was, here's my equation, right? X, I'm going to sub in X for 12 because X is time.
Well, then just write that in.
And just write it in. So guys, that was your work. Page, that's it. Hard day, yeah. 461. Numero. Number 4 to 6. Everyone should be able to do this on Monday. Exponential regression, how to work forwards and backward. That's it. You got 24 after look at your equation. 46. If you didn't get that, answer 22.7. Holla.